Hi, and welcome to the channel. So what prompts this video today about cleaning 3D printer nozzles is a couple of different things. Now, first thing you should do is if you get a plug nozzles, go to your manufacturer website and see what this suggests for your particular printer and nozzle, because that'll address what you have in particular. I can't address everything here. There's new filaments coming out every day, new printers coming out every day, different kinds of nozzles. What this video is meant to address is worst case scenarios and hopefully give you some ideas of where to go to get help if you can't figure it out. So the reason this particular nozzle prompted this video is because of how it works. So this is a Bondtech CHT nozzle, and what it does is the filament gets there to the beginning part, if I get to focus on it, and then it divides the filament after it's melted into 3 different parts so it contacts more surface area, and then it recombines it and puts it out the tip. That allows it to melt filament quicker, and it acts kind of like a volcano hot end because of that increased surface area. So you can print faster if you can melt filament faster, right? So super cool, except you can't do a cold pull on this. So cleaning a plug nozzle out becomes awful hard when you can't use your standard methods. So that's one of the reasons, because this is like $20 where a standard one is like $2. And I don't want you to be dissuaded from using something like this because, I mean, it's great. But the comment has been made that I don't want to spend $20 on a tip if it's just going to plug up and I got to throw it away. And I'm knowing a lot of people probably feel like that, and it's understandable, but there's always hope. And that's what this video is about, is bringing you guys some hope. You know, everybody's going to run across some, filament. It's probably going to be a silk or something like that. It's got a lot more additives in it, and your print settings aren't going to work. And then boom, you're going to get a failed print and plug nozzle. And it's just kind of part of the game. Like, it's going to happen. So we might as well kind of work on addressing it. A great place to start is a Prusa knowledge base. I'll put a link to that in the description. If your print manufacturer doesn't have a knowledge base, the Prusa one is fantastic. They've got a lot of great ideas, and it's transferable between printer brands, I'm sure. If it works on a Prusa, odds are it's going to work on whatever you've got. Even if it's not exactly the same, right? It'll at least give you an idea. So the second option is solvents. So this is MEK. MEK is super cool because it melts multiple different kinds of filaments. It can melt PETG. It's supposed to melt PLA. I haven't tried it. It does ASA. It does ABS. It's super cool like that. So if you take a tip that's got a plug in it, and you have the plug's ASA or PLA, you theoretically can throw it in a glass jar with a metal lid. And I'm just saying that because it melts plastic. So if you put it in a plastic container, it's the wrong kind of plastic, you might end up with a mess. So, a glass jar with a metal lid, and let it soak in there. Hopefully that'll loosen your clog up enough to be able to scrape it out with a needle, do a load, unload, clean out the rest of it, and maybe it'll get up and going again. Might save you your more expensive nozzle. And a good way to figure out what solvent will work for whatever filament you got is to Google what to use for vapor smoothing that particular filament. Now, I can't tell you every filament. There's new ones coming out like on a regular basis, but that gives you an idea. If they're using a favorite for vapor smoothing, then it melts whatever filament you've got. And so that is the second worst case scenario option, is solvents. You could soak them and then scrape them out with like an acupuncturist needle, because those are a lot thinner than a standard needle, and they make them in like 0.2 millimeter, whereas like a generic nozzle size 0.4, so they're smaller. Now, the worst case, the nuclear option, the one that isn't suggested but does work, is fire. So there's some things to be mindful of, like if you use a torch to melt the filament clog out of your nozzle, it's going to get a lot hotter than your hot end gets, right? Like your hot end might hit 300 degrees Celsius, whereas this is like 1200 degrees Fahrenheit. So you have to be kind of careful what you do here because you can actually melt your nozzle if you go a little too far. But it does work. I don't want anybody freaking out because this is MAP gas. The original MAP gas hit like over 5,000 degrees or something like that. This is MAP Pro. It's just a play on the name. They don't make that MAP gas anymore. It was spelled MAPP, and they're playing off the name. This is MAP and then Pro. And this is similar to like propane. A propane torch would work as well. They get to similar temperatures, I believe like 1300 degrees or something like that. So it's more than enough to melt brass. But if you are mindful of what you're doing and you take your needle nose pliers or whatever and you slowly turn the nozzle in the flame so it heats evenly, and you watch the filament and you watch to where it turns the ash stage, then you're done. You pull it out of the flame because that filament's going to melt and turn to ash long before that brass is going to melt, or whatever your nozzle's made out of, hopefully. So that's the worst case scenario. That's the scenario you might use if you're going to throw the tip away anyway, so you don't care, because it might wear out faster once you've heated it up that much. And what do you have to lose? I mean, if you're going to throw it away anyway, you're in a hurry because you need to finish a print up and you don't want to wait for a new tip to get there, why not use a torch? I mean, there's no reason not to. I mean, you're just going to throw that tip away anyway. So please don't blow me up too bad in the comments about that. I know it's a horrible idea. It's worst case scenario. Like, just when you've got to do it and you've got no other choice and you're already going to toss a nozzle. So there you go. There are some different solutions, or at least, ideas on how to approach, getting a plug out of a nozzle. What I found in the past is like, it won't be a certain filament that plugs it. It'll be like a combination of filaments. Like I've run ASA and then I tried to throw a silk PLA through. And so it was a combination of filaments that had built up in the nozzle that it had already partially plugged, but it wasn't bad enough to where it showed up. And then when the plug did show up, it was super bad. I would like you guys to use the comment section because there is new stuff coming out all the time and there's different combinations. I'd like you guys to, if you've got a favorite way of cleaning nozzles, is to put the kind of printer you got in the comments and say what your favorite way of cleaning the nozzle is and what the filament was. So that way we get kind of a live knowledge base, and it's ever evolving, right? So a new filament comes out and somebody's got a new idea on how to clean it. And so somebody can just skim through the comments and hopefully, you can help them out. So I appreciate it. If this video helped you at all, please hit the like. If you want to subscribe, I'd appreciate that. And good luck, guys.